With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our today's question is on the screen right now, and the question is, there are two vessels, each of them contains 1 moles of a monoatomic ideal gas. Initial volume of the gas in each vessel is 8.3 into 10 the power minus 3 meter cube at 27 degrees centigrade. That means the temperature and the volume of both the vessels are same, and both of vessels containing the same gas, that is monoatomic ideal gas. Equal amount of heat is supplied through each vessels. The amount of heat is also equal for the both vessels. In one of the vessels, the volume of the gas is doubled without change in its internal energy. The volume of first vessel is doubled because of giving the heat, that is V initial equals to V final, that is 2B, without change in its internal energy. There is no change in its internal energy, that means delta U is 0. Delta U is 0, that means there is no difference in temperature. Temperature is remain constant, whereas the volume of the gas is held constant in the second vessel, and for the second vessel the volume is not changing. That means if there is no changes volume, that means the work done is 0. The vessels are now connected to allow free mixing of the gas. Now both vessels are connected and there are free mixing of both the gases. Find the final temperature and pressure of the combined gas system. Okay, this is our question. I hope you all understand it. Now we are going to start the solution. Let us consider that this is two vessels. These are two vessels. These are separated. This is vessel 1 and this is vessel 2, filled with the monoatomic gas. At first, the initial temperature is same for all the vessels, that is 27 degrees centigrade, and we will change it into Kelvin. 273, it is 300 Kelvin. T initial is same for both the vessels. Similarly, the V initial is also same for both the vessels, that is given in the question. It is 8.3 into 10 the power minus 3 meter cube, and number of moles for first vessel, that is 1 mole given in the question, and N2 is equal also 1 mole. This is the gas N1, this is N2. Okay, now, and the given heat, the heat given to both vessels are also same, delta Q and delta Q. Now the volume of the gas is doubled without change in internal energy for the vessel 1. Now we talking about the vessel 1. We are going to talk about the vessel 1. Now for the vessel 1, for vessel 1, it's given in the question that its volume, final volume is changed into double of 2bi. Okay, and change in internal energy 0, that is given in the question. That means there is no change in temperature. Temperature is constant, and when the temperature is constant, this process is known as isothermal process. Okay, isothermal process. And for isothermal process, we are going to apply the first law of thermodynamics, and this law is delta Q1, because it's for vessel 1, equals to delta U plus delta W. Delta U is 0. Now the delta Q1 equals to the work done, and the work done for isothermal process is given by nRT log V final upon V initial. Putting all the values, we will get delta Q1 is equals to number of moles 1, number of value of R 8.3, temperature 300 Kelvin, log V final is 2bi upon Vi, that is log 2, Vi cut. Okay, so the value of delta Q1 after solving all things, we will get 207.9 R or if you solving by without putting the value of R, or with putting the value of R. So this joule. Okay, so this is the heat for the vessel 1. Now for vessel 2, now we are going to talk about vessel 2. For vessel 2, the heat is delta Q2 is again the first law of thermodynamics, delta U plus delta W, and it is said that for vessel 2 there is no change in volume constant, and when volume is constant, that means the work done is 0. This is 0. Now delta Q2 is equals to delta U, that is our internal energy, and the internal energy for ice volume is constant, that means this is an isochoric process. Okay, where volume is constant, that process is known as isochoric process, and for isochoric process the internal energy is given by NCV/dt. This is for vessel 2, to NCV/2 dt. Now the value of delta Q2 is equals to number of moles 1 into the value of Cv for monoatomic gas is 3/2 R. There is monoatomic gas, and for monoatomic gas the value of Cv is specific heat at constant volume. Cb is specific heat at constant volume, and its value is 3/2 R, and this is our delta T. Now from the question we know that delta Q1 is equals to delta Q2. We will read in the question that we will given the same heat to the both vessels. Okay, that means delta Q1 is equals to delta Q2. Okay, and we already find out the value of delta Q1, and this value is 207.9 R equals to the value of delta Q2. This is this 3/2 R delta T. From here, solving this, we will get delta T is equals to 138.6 Kelvin. This is the temperature difference for vessel 2. This is 138.6 Kelvin. This delta T is basically T final minus T initial equals to 138.6. We have to find out the T final of the for vessel second. T final equals to 138.6 plus T initial. The value of T initial is 300. So basically our T final is equals to 438.6 Kelvin. This is our final temperature for vessel 2. Now in the question it is said that we are going to intermixing of gases. That means we will remove the portion. This portion we are going to remove. Now the gas is intermixing in both vessels. Okay, before this volume is V, and this volume is also V. Now the total volume, it is behaving like a whole system. When the partition is removed, both the vessels are behaving like a one system. Okay, this is now our one system. Now for this system, the number of moles NT, total number of moles is equal to N1, number of moles for gas 1 or for vessel 1, and N2, and this is 2 mole because N1 is 1, N2 is 1, it is 2 mole. Now after mixing the gas, our T final is equals to the temperature of mixture. T final is become the temperature of the mixture. Now for the whole system, the internal energy is given by U1 plus U2. Putting the values for the system, internal energy is given by NCV/dt, and when we are written for the system, it is N total CV, total temperature of the mixture, that is Tm equals to N1 CV T1 for the vessel first and N2 CV T2 for the vessel second. Now CV is common. Let's cut down. Now putting all the values are given in the question, and putting all the values we will get the value of Tm. Finally we will get the value of Tm and it will 369.3 Kelvin. This is the temperature of mixture after mixing the both vessels or after mixing the gases of both vessels. Now from ideal gas equation, now we have to find out the final pressure also. This is the mixture temperature of mixture. Now we have to find out the final pressure after mixing the gases of both vessels. So from the ideal gas we will know that P final V equals to nRT. This is our ideal gas equation, PV equals to nRT. Now we can write P final as PM, pressure of mixture, dot. Now the volume of the system becomes 3V. Why? Because this after giving the heat, the volume of first vessel is become 2V. Remember, when we are giving the heat to both the vessels, the volume of the first vessel becomes 2V. That means this V and this remains constant. Now the total volume becomes 3V. Okay, so we are putting the value of V is as 3V equals to nRT. Number of moles is 2 into R into temperature. Already find out the temperature of mixture, that is 369.3 Kelvin. Now the volume of P M, after putting all the values we will get 2.462 into 10 to the power minus 5 Newton per meter square. So this is our pressure of mixture. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.